In this video, we'll be taking a look at logical equivalence and tautological equivalence. Let's turn to it. All right, so we say that two propositions are logically equivalent to one another if and only if they have the same truth conditions. And we say that two propositions have the same truth conditions if and only if, no matter what situation you place those propositions in, when one is true, the other is true, and when one is false, the other is false. So the idea is there's no situation whatsoever that one of the propositions will turn out to be true and the other proposition will turn out to be false. When that's the case, they're logically equivalent, and as far as FOL is concerned, those propositions have the same meaning. All right, so let's look at an example of a proposition then that is two propositions that are logically equivalent to one another. All right, so first, this sign here is the sign that represents logical equivalence. So it's saying of this conjunction and this conjunction that they are logically equivalent. All right, so let's take a look at these conjunctions. So one of the first things to notice is that for both of these conjunctions, one of their conjuncts says that A is numerically identical to B. So they're saying that A and B are the very same object. A and B are two names for just one object. And recall that for a conjunction is true if and only if all of its conjuncts are true. So one possibility for this first conjunct is that it's false, that A and B are different objects. They're not one and the same. So under that situation where A is identical to B is false, it's going to turn out that both of these conjunctions are false. We don't even need to know whether A is a cube or whether B is a cube. We would just already know that those conjunctions are false and will always share the same truth value given case 1. All right, so our other case then is where, or one of our other cases then, is where A and B really are just the same object. So in that situation, we don't yet know whether these conjunctions are true or whether they're false. But what we do know is that under this situation where A really is B, then no matter what shape A is, B will also be that shape, and no matter what shape B is, A will be that shape as well. So one situation that would make our second conjunct false is the situation in which A is a non-cube of some sort. Okay? If A is a non-cube, that'll be false because our second conjunct is false. But because this is under the assumption that A and B just are the same objects, that'll mean B is a non-cube. And since that means this conjunct is false, the conjunction will be false. So again, no deviation of the truth values for that situation. The other possibility, under the assumption that A and B really are identical, is that A is a cube. But then again, since this is under the assumption that A is identical to B B is going to have to be a cube. But in that situation, since both of the conjuncts of the conjunctions will be true, this will be true, and this will be true. There is no way whatsoever for these propositions to deviate in truth value, and hence they are logically equivalent, and as far as FOL is concerned, they mean the very same thing. All right, so we can get a better picture, a better understanding of logical equivalence by taking a look at tautological equivalence. And the reason for that is tautological equivalence is a special subset of logical equivalence. So propositions are tautologically equivalent if and only if their truth functional connectives determine that they have the same truth conditions. So if the truth functional connectives, for instance, the ones we've seen so far is negation, conjunction, and disjunction, we'll see material conditional and biconditional in the future. But if the meaning of those by themselves forces the propositions to have the same truth conditions, then it's going to be tautologically equivalent. And since truth tables are only sensitive to the truth functional connectives, we can use truth tables as a means then for evaluating whether propositions are tautologically equivalent. So if we take a look at this joint truth table here, we'll notice that we have these two propositions. And if you recall De Morgan's law, you'll be able to see that these are going to be logically equivalent because they're just an instance of De Morgan's law. Right, so what do I mean by that? If we think about, and this is technically incorrect, but if we think about distributing this negation into the content of the parentheses, and we just make sure to flip the conjunction sign to a disjunction sign, that would output this sentence. And that's what De Morgan's law tells us that we can do. It also tells us we can go the other direction as well. But the point is, the reason why we can go in those directions is because it saves the truth value of whatever that sentence is. It's a truth-preserving move. All right. So what we would notice if we do this truth table, then for each of our situations, in situation 1, when P and Q are both true, then it turns out that for both of our sentences, they turn out to be false. And when P is true and Q is false, it turns out that both of the sentences we're taking a look at have to be true. And when P is false but Q is true, it turns out that the truth value of the sentences we are looking at are true. And this is supposed to be a 4. And when P is false and Q is false, again, we see that the sentences that we're examining with these truth tables would have to be true. There's no deviation between these. As a result, they are tautologically equivalent, and since that's a special case of logical equivalence, it'll turn out that these propositions are also logically equivalent. Okay, so the moral of the story then, when we're worried about tautological equivalence and we want to check tautological equivalence, what we're doing is looking at the main connectives for the sentences that we're doing a truth table on. And if we see that the columns mirror each other, that they're the very same, and there's no deviation whatsoever, then those sentences are tautologically equivalent. All right, so before ending this video, I want to talk about the relationship between tautological equivalence and logical equivalence. And as we can see in this diagram here, tautological equivalence is fully encapsulated in logical equivalence. And what that's supposed to be representing is that for any two propositions that are tautologically equivalent, they will also be logically equivalent. But the reverse doesn't hold. It's not the case that for any two proposition that is logically equivalent that they must be tautologically equivalent. Some of them will be, but they don't have to be. All right? And in fact, we can see that in the case of the two propositions that we were looking at the beginning of this video. A is identical to B and A is a cube, and then the conjunction A is identical to B and B is a cube. So if we do a truth table for these propositions, we'll see that the columns for their main connectives will not mirror one another. There will be a difference. So let's see that that turns out to be the case. We've got, because we have three types of propositions, A is identical to B, A is a cube, and B is a cube, we have three propositions in our reference column, and we have 8 rows, 8 situations. All right, so let's look at the first conjunction first. In that situation, it turns out A is identical to B is true, and A is a cube is true, and a conjunction is true if and only if all of its conjuncts are true. So in situation 1, we get the value true. Again, in 2, both of the conjuncts end up being true, so it ends up being true. But A is a cube is false in the third case, so the conjunction is false. Same with the fourth case. And then I can see for the rest of these cases, since the A is identical to B will be false, that they're going to be false in all those cases. So for the next 4 cases. Okay, so now let's look at the truth conditions for our second sentence, A is identical to B and B is a cube. So again, we're going to get true for our first situation because both of the conjuncts are true. But in our second situation, the right conjunct is going to be false, and so we get false for the second situation, and we get true for the third situation. And then, since that's false, and these are false for the next 5 rows, we'll have false come in here. So false, 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 false. That's the values that we'll get. And then when we compare our 2 columns, we'll note that they do in fact differ. They're not the same in case 2, and they're not the same in case 3. And the reason why that is because if you'll recall, our truth tables are only sensitive to the truth functional connectives. They're not sensitive to the meaning of predicates. And while you might confuse the identity sign as being a truth functional connective, it's not. It's a predicate. It symbolizes the identity predication. So our truth tables end up ignoring the meaning of A is numerically identical to B. And that's why we end up getting that deviation here on our truth table in the columns of these main connectives, whereas when we think it through, we see that these statements are in fact logically equivalent. So even though these two propositions here are logically equivalent, they are not tautologically equivalent. All right, that wraps up this video on logical equivalence and tautological equivalence. Thanks for watching.